All right, welcome back for lesson 4.1 video 2. So we're going to start with a word problem here. So let's take a look. So it says Manisha and Holly have 14 more days to finish reading the same novel for class. Manisha plans to read 9 pages each day, while Holly plans to read 20 pages each day. Assuming Holly and Manisha both maintain their reading plan, when will Holly catch up with Manisha? Who will finish reading the novel first? Okay, so if we take a look here, notice that Manisha, she is on page 96 of 220, and Holly is on page 6 of 220, right? So we're going to create an equation for each of these girls in terms of how they're reading, and then we're going to graph them using Desmos because it's a word problem, and we're going to find what's going on here with who's going to catch up, who's going to finish first. So let's talk about what X and Y represent, right? So notice it says here, 9 pages and 20 pages each day. So this is your rate, this is your slope. And notice it says pages each day, page per day, Y per X. So this is telling us that X are the days and Y are the pages we read. So for Manisha, she reads 9 pages per day, that's her slope. And she's already on page 96. That's going to be her B value, right? Her starting point. So for Manisha, her equation is going to be, so this is for Manisha, her equation is going to be Y equals 9x plus 96. 9 pages per day, already on page 96. For Holly, right? So Holly reads at 20 pages per day, and she is on page 6, right? That's her B value. So Y equals 20x plus 6. And again, you better see Holly reading at a faster rate because she's so far behind already on Manisha. So now we're going to graph this in Desmos. I want to talk about the domain and range real fast so we can create a nice window in Desmos. So for our domain, right, our X's, they have 14 more days to read the book. So X are the days, so our domain is between 0 and 14. If you recall from lesson 3.1, I think, that's how we create that domain. And then the range would be the number of pages in the book. So 0, 2, and the total number of pages is 220. Less than Y, less than or equal to 220. Okay? So days and pages. So I'm going to graph this on Desmos. Okay, so I'll type in Y equals 9x plus 96 and Y equals 20x plus 6. Okay, that's going to go into Desmos. Again, I'm going to go over here to the wrench and change my scale. I'm going to let my x-axis be from 0 to 14 and my y-axis from 0 to 220. And then I'll just click in it so I can see the axes. So I'm going to draw a little picture right here, right? So here is my picture. So we went from 0 to, so I have 0 to 13 on my page right now, and 0 to 200. So the red graph is Manisha. She's up here. This is Manisha. And then the blue graph is Holly. She's right about here. This is Holly. So the question is, when are they going to read the same number of pages, right? Well, it's right here at the intersection point, right? When do they catch up? And if we find that point, we just use Desmos and click on it, if you see. And there's the point. So 8.2170, right? If I round, so that's the point, 8.2170-ish. So the first question was, when will Holly catch up? She'll catch up after 8 days. So Holly will catch up after 8 days. So that's the first question. Then the second question is, who's going to finish first? Well, notice Holly's line, right? Holly's line. At this point, at this intersection point, now Holly has more pages read than Manisha, in a quicker amount of time because her graph is above Monisha. So she has higher y values for the same x values. So what that means is because Holly's graph is above Monisha's here, when it reaches 220, and I can show you that by dragging. Hold on just a second. So when it reaches 220, which is right along this line here, notice that 220 is going to hit Holly's graph first. So Holly will finish first. Holly finishes first. So you notice that Monisha starts with more pages read, but because Holly is reading at a faster pace, she catches up to her and eventually takes over her and finishes the book first. So that's that whole like, what do you call it? The tortoise and the hare, right? Slow and steady wins the race. All right, last question here, and then we'll be done with 4.1. So we're going to take a look at this question. Let me clear that. Okay, so here we go. Last question. So it says, what is the solution of this system? So we have two equations in slope-intercept form, no big deal. So let's just graph them. So the first one here, y equals 2x minus 3. So your b is minus 3, so go down 3. Your slope is 2 over 1. That goes up 2 and right 1. Up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, right? So there's your line. Again, as best you can. So this is y equals 2x minus 3. Okay, the blue one, again, is also in slope-intercept form. So y equals negative 5x plus 6. So the b is 6, so you go up 6, 1, 2, 3, 4, 5, 6. The slope is negative 5, put that over 1. So you're going to go down 5 and right 1. 1, 2, 3, 4, 5, 1. 1, 2, 3, 4, 5, 1. Notice when I count this slope, I cross the line, right? In the first example we did in the first video, when I counted the slope, it landed on the other line. But this one crosses it. 2, 3, 4, 5, down 1. And then I can do one off the graph. All right, there's this line. Okay, and that's the equation y equals negative 5x plus 6. So the problem here is that now I don't know exactly what that intersection point is, right? I have to estimate that point. If I look at my graph and estimate that, that looks like the point maybe like 1.3, negative 0.2, I don't know, right? It's an estimation. Now I can go to Desmos real fast, and I'm going to. And I'll type this in. So y equals 2x minus 3, and then y equals negative 5x plus 6. And again, if I click here, there, 1.3 and negative 0.4. Again, it was an estimation, right? It's not exact. So what does this mean in terms of graphing? Graphing has its limitations, right? So is there a better way? And yes, there is. So when you do 4.2, 4.2 is going to be called substitution. This is another method of solving these systems. 4.3 is called elimination. Elimination. These are both algebraic ways to solve systems of equations, and you're going to see that your answers don't have to be nice integers or even nice fractions. Okay. All right. So good job today. Thanks for watching these videos. We'll see you next time.